Okay, so say I want to solve this one, sine cube theta minus sine theta, ignore the splotch, equals 0 for one period. So this is not a quadratic, it's a cubic, but I still can see I can factor it. So I'm going to go ahead and factor it, and I can factor a sine out. So sine theta times sine squared theta minus 1 equals 0. So factoring again, just like you would factor an x out. Well, now it's a quadratic, and now it's a difference of two squares, so I can factor it further. So I still am going to have a sine theta on the outside. Then I'm going to have difference of two perfect squares, so sine theta minus 1, sine theta plus 1 equals 0. Okay, so it's factored. I'm going to set each part equal to 0, so sine theta equals 0. And I'm going to try to solve that. So where does sine theta equal 0? I'm looking for one period. So theta is where my y is 0, so that would be over at the pi and at the 0. So I'm going to say theta equals 0, pi, and I'll go 2 pi just so I can get the entirety of a period in there. So, okay, that's where my y is 0. So let's see the next part. Sine theta minus 1 equals 0. So sine theta equals 1. So I'm looking for where sine theta is 1. Again, the y is 1 up here, so that's going to be pi over 2. So here theta equals pi over 2. And that's it. When I go around, it's not, within that first circle, it's not going to hit this again. Okay, so then I have sine theta plus 1 equals 0. So sine theta equals negative 1. So where does y hit negative 1? And that would be down here. So theta equals 3 pi over 2. So all of these are my answers. I'm going to say theta equals 0, pi over 2. I'm just going to write them in order. Pi, 3 pi over 2, and 2 pi. All of those are solutions to this equation.